Okay, solving systems of equations. Systems in two variables. First of all, we have types of equations we need to talk about. We have consistent equations, which these are equations that have at least one solution. There are two types of consistent equations. Independent, where there is exactly one solution, and these are intersecting lines. And then dependent, which have infinitely many solutions, and these are coinciding lines, meaning two lines, two different equations, but the same exact line. Then we have inconsistent, which there are no solution for. These are parallel lines. Okay, looking at this system of equations, both of them are in standard form. When you're given an equation in standard form, you need to find the slope. The easiest way to find the slope of the line is to take negative a over b. Remember, ax plus by equals c? Take negative a over b. So line 1 has slope of negative 3 over negative 2, which is positive 3/2. The next one has the slope, so line 2 is negative 1 over 1, which is negative 1. Okay, they have different slopes. Any pair of lines that have different slopes are independent. There will be exactly one solution. If they have the same slope, they could either be dependent or inconsistent. If they're dependent, then they're the same slope with the same y-intercept. Inconsistent, same slope with different y-intercepts. Okay, solving algebraically. Okay, solve by substitution. With this, you want to have one of your variables solved for to begin with, or have one simple step and then be able to solve it that way. Here, x equals y plus 2, so x is solved for. I'm going to take the y plus 2, plug it into the other equation for x. So we've got 2 times y plus 2 plus 3y equals 8. Distribute 2y plus 4 plus 3y equals 8. Combine like terms. 5y plus 4 equals 8. Subtract 4. 5y equals equals 4. Divide by 5. Y equals 4/5. Now I'm going to take this and plug it into my other equation to solve for x, because you have two solutions. Two equations, two variables, two solutions. So plug it in right here. The easiest way to do it, x equals 4/5 plus 2, which real simply is x equals 2 and 4/5, and you can leave it like that. That's perfect. Write your ordered pair for your solution, 2 and 4/5, and then 4/5. Okay, 2.8, 0.8. Here's another one to solve by substitution. This one, both equations are in standard form, but in one simple step, I can take one of them and have the other variable solved. I can take this first equation and subtract 7x from both sides. Okay, so that's going to be y equals 9 minus 7x. Plug that in for y into the other equation. 5x minus 9 minus 7x equals 15. And then go through the process, distribute. Now here we have to distribute a negative 1. 5x minus 9 plus 7x minus 9 minus a negative becomes a plus equals 15. Combine your like terms. 12x minus 9 equals 15. Add 9 to both sides. Divide by 12. X equals 2. Now, plug this in right there and solve for y. Y equals 9 minus 7 times 2, which is 9 minus 14, which is negative 5. Write your ordered pair, 2, negative 5. Solving systems of equations by elimination. In this, here we have two equations. They're both in standard form. None of them have one simple step I can do to get a variable by itself. But if I take this second equation and multiply the entire thing by 2, that's going to give me a positive 4y and a negative 4y. And if I combine them, I can eliminate the y's. So let's do that. 2. Now I'm just going to draw a line through this so that I don't get confused, because now I'm going to add these two equations. So I've got 15x, 4y minus 4y eliminated, equals 5. Divide by 15. X equals 1/3. Okay, now pick one of the two equations and solve for. Plug this in and solve for. I'm going to pick the first one because 3 times 1/3 is 1. Easy multiplication in my head, so I picked that one. 3 times 1/3 plus 4y equals negative 1. 1 plus 4y equals negative 1. Subtract 1. 4y equals negative 2. Divide by 4. Y equals negative 1/2. Write the ordered pair. 1/3, negative 1/2 is the solution. Next one. Here's a system of equations. It's in standard form. I don't see anything that looks real easy like I can solve for right off the bat. But I do have the 2y and the negative 5y. If I take this first equation and multiply this by 5, that'll make this a positive 10y. Take the second equation and multiply it by 2. That's going to make this a negative 10y. And I will be able to eliminate very easily. When we do that, we have 7.5x plus 10y equals 100. Then we have 2.5 times 2 is 5x minus 10y equals negative 50. Combine them by adding down. We've got 12.5x. These two are eliminated. Equals 50. Divide by 12.5. X equals 4. Pick one of your equations to plug into and run with it. It does not matter which one. I'm going to pick the first one just for fun. 1.5 times 4 plus 2y equals 20. 6 plus 2y equals 20. Subtract 6, 2y equals 14. Divide by 2. Y equals 7. The ordered pair is 4, 7. Okay, this one says to solve. I'm looking at it, I see I can easily get x or y by itself, but without making any changes to this, this is set up to do elimination. I've got positive y, negative y. If I just combine them, add, we've got 4x, positive y minus y is 0, it's eliminated. equals 8. Divide by 4, x equals 2. Plug in. 2 plus y equals negative 2. Subtract 2, y equals negative 4. The solution is 2, negative 4. Done. Okay. As always, I'm all about solving problems. Madison is considering leasing a car for 2 years. The dealership says the car she wants is $326 a month with $200 down. However, if she wants, she can put $1,600 down, and her payment would be $226 per month. What is the break-even point when comparing the two options? Which lease should she choose if the down payment is not an issue? What is the break-even point? That means when are they going to cost her the same? So what we're going to do is we're going to write two equations. We have two linear equations. $326 per month is a rate. Okay. $200 down is a y-intercept. Okay. So we're going to write a system of equations and solve it. Okay, the break-even point. Here we have with lease 1, I'll call it L1, lease 1, line 1, whatever. The total cost is going to be $326 per month times your month plus 200. The other one is your total cost will be $226 per month plus 1,600. Okay, we are going to, here's L2, solve this system of equations and find out when they are equal. So if we do $326 per month plus 200 equals $226 per month plus 1,600. Okay, set this one equal to that one and solve for M. How many months until she breaks even? Subtract 200. Subtract 226M. And we've got 100M equals 1,400. Divide by 100. M equals 14. So after 14 months, she has broken even with the cost of the car that with the amount of money that she's paid for the car. So in 14 months. Now, which lease should she choose? Okay. Well, actually, if you graph these, okay, lease 1 would start low at $200 and then increase from there. And lease 2 would start at $1,600 and increase. But the one starting at $200 is going to increase much more rapidly than the one starting at $1,600. So here is lease 2, here is lease 1. Okay, this is the point after 14 months. Okay, what the actual cost is, we need to calculate that out if we wanted to. But look at the graphs. Okay, lease option number 1 is increasing rapidly, and at this point, this is where they are the same. At that point, the cost is much higher than the cost of the other one. So this one, she pays more up front, but in the long run, she pays less. So I would say lease option 2 is the one to choose because it's going to cost you less in the long run.